Okay, so this is a preview lecture for Organic Chemistry 1, Lesson 1. And in that lesson, there are 6 objectives. The lesson plan for this is on your D2L website. And the six objectives are these. Objective number 1, identify the number of protons, neutrons, and electrons in an atom in its ground state. Number 2, differentiate between core and valence electrons. I'm not going to spend any time on this one or this one unless you have a question. We'll talk about this a good bit, I suppose, but not much right now. Objective number 3 is ionic, covalent, polar covalent bonds. Be able to identify which is which. Generally speaking, people in principles of chemistry get that pretty good. Now here's the one that people struggle with. Given a molecular formula, draw a Lewis, Kekule, or condensed structure. And that we're going to spend some time on, both here in a preview video and also in class. Formal charge, people struggle with this also. This is a bit shorter than objective number 4, so let me just put a little X next to that one, or a plus next to it. And then finally, atomic orbitals and molecular orbitals and VSEPR theory and molecular orbital theory and so on. So we're going to go pretty lightly into this. People don't usually love it by the time they get to this course. In other words, there's some holes in your understanding, but we won't need to go real deep into this. So I'll touch on that. All right. So the first thing we're going to cover though in this video is objective number 4, and then we'll go to 5 and 6. Okay. So objective number 4 is given a molecular formula. Draw a Lewis, Kekule, or condensed structure. Okay, so here's some molecular formula. Lewis dot structure. Kekule, which I'm going to, which clearly I've misspelled. Kekule and a condensed. All right, and sometimes this is called line bond. Sometimes it's called skeletal. All right. So let's start with the simplest organic compound that we've got, CH4. The Lewis dot structure for that, without teaching how we get that, I may do that under a separate video. I've got one, but it's pretty bad. There's a Lewis dot structure. The Kekule structure doesn't make a whole lot of sense right now in this context, and you'll see why in a second. The condensed structural formula for that is CH4. Okay, it's a molecular formula for ethane. That's for methane. For ethane, it's C2H6. The Lewis dot structure is okay. Now here's where we can begin to talk about the Kekule structures. It turns out that there are a few rules here. Rule number 1, they're in your textbook. Rule number 1 is that all carbons are going to be implicit. We're not going to draw the carbons out. We're going to draw all carbon-carbon bonds as a line. Okay? And we're going, that's rule number 2. Rule number 3 is we're going to assume that all carbons have 4 bonds. Okay? You see the 4 bonds here? And all carbon bonds are just drawn as a line. All carbon heteroatom bonds, that's carbon to oxygen, carbon to sulfur, carbon to nitrogen, carbon to I already said oxygen. They're going to be drawn out, but the other letter is going to be given. The atomic symbol is going to be given. But for carbon-hydrogen bonds, they're going to be just implied. In other words, we're not going to draw them there at all. Okay? So there's a carbon. We know it's a carbon because it's the end of a line, or it's a terminus, or a joint. And so we know it's a carbon. We know it has 4 bonds. One of them is drawn. And so the 3 that are not drawn must be carbon-hydrogens, and that's exactly what it is. Okay? Now, this structure is so simple, it's hard to imagine why we would really want something like that. Why don't we just draw it all out? But you'll see when we get bigger structures, it's going to be nice to be able to have all the same meaning in it, but not take nearly as much time. Okay, and the condensed structural formula, which most people at this stage of the game prefer, CH3. I guess students prefer this or this over this. But you're going to have to get used to this because this is how the scientists write. And I think later you'll agree that it's far more efficient. Okay, so a condensed structural formula has some structural hints in it. CH3, CH3, so you can tell that these two carbons are not, you know, that you can tell, for example, that this is not, you know, CH, CH, H, right? You can tell it's not that. Of course, we know that there's other reasons we know it's not that, but this has some structural hints in it, but not a lot. Okay, let's go on to propane. Propane is C3H8. Yep. Okay. So the Lewis structure for that, I'm going to have to draw kind of small here. Right, is that. Okay, the calculate structure is that, because I have a carbon, and a carbon. This carbon, how many bonds are shown? Only one. So it must have 3 hydrogens on it, which it does. Like this carbon is this. Boom. Right? That carbon, 2 bonds are shown, so it must have 2 hydrogens that are not shown, right? Boom. Boom. Okay. And then this last one, there's only 1 bond shown to that carbon. Okay, so the other 3 must be hydrogens. And the condensed structure formula for it is CH3, CH2, CH3. Okay? You can see up here with methane, it's the same. Here, you can see that there's more information. This is the molecular formula. Here's the condensed structural formula. Here's propane. Here's propane. Okay? You can see there's more information in this. This has more hints to it. Sort of tells you what things are bonded to what. Okay? And that, of course, is the most sparse, most bare bones, but it's also super efficient, and that's what we're going to use a lot. Let's do isopropane, or no, not isopropane. Let's do 2-methyl propane. You would have no way of knowing what that is, right? So I'm just going to do it. It's C4H10 is the molecular formula. And this is where we start to get to see where this stuff is valuable, okay? Every carbon's got 4 bonds, so I'm just going to go 1, 2, 3, 4. I knew that one had a hydrogen on it because I already had 3 bonds. 1, 2, 3, 4, right? Okay, so that's 2-methylbutane. Starting to get a little gummed up here. It's going to look like that, though, as in its line bond or its calculate structure, skeletal structure. And this condensed structure formula is going to be kind of like that, except we're going to condense all the hydrogens down. So it's going to be CH3, CH, CH3, CH3. Right? You can see why I think students like that, because it's a bit condensed. This is a bit hard to see now. This is condensed, but it's still pretty nice. And that's what we're going to have to get used to. All right. Next, let me make a sub point here though. CH, CH3, CH3. Sometimes this is drawn like this. Can you see how these are the same thing? I think your eyes maybe serve you better than me giving a long description about what's going on here, right? That CH3 is bonded to that carbon. Okay, it's the kind of thing that if you get used to it, it gets easy, and until then, it's pretty painful. Okay, now here's the best commercial I think for line bond structures. How about cyclohexane, which you don't have to know what that is yet. Okay, it's C6H14. Okay, and it looks like this: C, 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 C. Oh, C6H12, sorry. Okay. You can see each of these has got to have 2 bonds yet because I only had 2 there in the first place. All right, that's cyclohexane. All right, here's the line bond structure for it. And the condensed structural formula for this is CH2, CH2, CH2. In this case, it's not so useful. All right. So this is objective number 4. Objective number 4 was, given a molecular formula, draw a Lewis, a calculate, right here, given a molecular formula, draw a Lewis, a calculate, or a condensed structure for that. Okay, I'm gonna do objectives 4 and 5 under a different video.